Hi guys, Miss Malik here again. We're just going to pick up where we left off with exercise 4a from our Essentials textbook. We're looking at the remainder and factor theorems. So we've just done an example with the remainder theorem in the first part of the video. We now look at the factor theorem. X plus 1 and x minus 2 are factors of 6x to the 4 minus x cubed plus ax squared minus 6x plus b. We want to find the values of a and b. So the factor theorem is a rule we need to know, and that states that ax plus b is only a factor of p of x if p of negative b over a equals 0. So in the example we have of x plus 1 and x minus 2, x, the coefficient of x is 1, so a is 1 and b is 1 as well. So negative 1 over 1 would be negative 1, and for x minus 2, a would be 1 and b would be negative 2. So negative 2, which is positive 2 over 1, is 2. Let's see what we do with those. So p of negative 1 has to equal 0. Because x plus 1 is a factor, it means that we have no remainders. So let's try that. 0 should equal 6 times negative 1 to the 4 minus 1 cubed plus a negative 1 squared minus 6 times negative 1 plus b. We end up with 0 equals 6 plus 1 plus a plus 6 plus b. Let's rearrange that so we get a plus b equals negative 13. So we've got one piece of information. We've got an equal sign, but we have two variables. So we can't solve right yet. Let's have a look at x minus 2. That would mean that p of 2 would have to equal 0. So when we substitute 2 into x in our equation, it must mean that we get 0. Let's do that. 0 equals 6 times 2 to the 4 minus 2 cubed plus a times 2 squared minus 6 times 2 plus b. We get 0 equals 96 minus 8 plus 4a minus 12 plus b. Rearranging gives us 4a plus b equals negative 76. We now have two equations and two variables. What would we usually do if we had two equations and two variables? Simultaneous equations. We could eliminate something in order to solve one of our variables. Let's have a look at what we've got. 4a plus b equals negative 76. A plus b equals negative 13. If we subtract a plus b equals negative 13 from 4a plus b equals negative 76, we're going to get 3a equals negative 63. Be careful. Make sure that you also subtract negative 13 from negative 76. Often people will subtract on the left but forget to subtract on the right. Solving for a gives us a equals negative 21. What would we usually do when we know what a equals? We haven't finished. We need to solve for b as well. That's easy. We just substitute a equals negative 21 into our equation, either of our equations, but a plus b equals negative 13 is probably the easiest. Negative 21 plus b equals negative 13. Rearranging, it gives us b equals negative 8. Let's solve a polynomial equation. So they tell us p of x equals x cubed minus 4x squared minus 11x plus 30. They want us to factorise that and then solve the equation. X cubed minus 4x squared minus 11x plus 30 equals 0. Let's first find a factor of p of x. So trial and error, you would start with probably 1 and then try negative 1, 2, negative 2, 3, negative 3, etc. until you found a value of p of x, until you found a value of x where p of x would give you 0. This would tell you that give you a factor. When we substitute 2 in for x, we end up getting 0. You can check that out if you like. So that means that x minus 2 is a factor. The second part is to do the division. So we would set up the division as we did in part 1 of this video, and we would divide x minus 2 into x cubed minus 4x squared minus 11x plus 30. We would find that the solution to that would be x squared minus 2x minus 15. That tells us that x minus 2 times x squared minus 2x minus 15 equals x cubed minus 4x squared minus 11x plus 30. We're not quite there yet. We've found one factor, and we've found a quadratic factor. We want to find linear factors. We need 3 of them in total. Let's now cross multiply with our x squared minus 2x minus 15. By doing that, we get x minus 5 and x plus 3 being our two linear factors there. We already have x minus 2, meaning that our three linear factors there are x minus 2, x minus 1, and x plus 3. We're not quite there. We want to solve for x. We want to be able to say what x can equal to solve our p of x. We now factor it. X minus 2 equals 0 means that x has to equal 2. X minus 5 equals 0, x would equal 5. And x plus 3 equals 0, x would equal negative 3. Let's do that on the cas. First, they want us to factorise p of x, and then they want us to solve the equation. Let's go about factorising. We go to the main screen, we type in the equation, or we type in the expression x cubed minus 4x squared minus 11x plus 30. We then highlight it. There it is there. Go to interactive, go to transformation, and go to factor. We then click exe, or we click on factor rather, and it gives us this. It tells us the factors are x plus 3, x minus 2, and x minus 5. We're almost there. We've factorised it. The next part tells us to solve the equation. Here are our factors. What we need to do now is copy and paste them. This one here, that little up arrow there, means copy. So if we highlight x plus 3, x minus 2, x minus 5, and then press that button there, that up arrow there, it copies it. We then click the down arrow, and that means paste. And it pastes it onto a new line. We can then use it. Let's highlight that. When we highlight that, we then go to interactive, into equation, and to solve. Copy and paste are really handy buttons to know, so keep that in mind. The cross next to the copy button is cut. Once you click solve, it takes you to this page here. In the equation box, we have our x plus 3, x minus 2, etc. And then the variable should be x. We're telling the calculator we want to solve for x. That's why it has to be x. There it is there. We click OK, and there you have it. It tells us x equals negative 3, x equals 2, and x equals 5. There they are there. Quite simple, but a few more steps than the other things we've done on the cas so far. That's it, guys. We have completed exercise 4A